Any solution has pros and cons. So you have to identify. So what's the pros and cons for running bigger boxes? Because at the end of the day, that would be also whether we respond to that. That question to all of you.
If you have many machines, for instance, you need to figure out if you how you configure the network, how they will contact with each other, how they will get the information, how you will say, okay, I know the locality of the data. In addition, if you need to get the information from the nodes that, like the data is not in your node, so the input and output will take more time, not like if you have the data in your machine. So this is what's funny, that it's dependent on the situation.
And what are the pros?
So the advantage of having multiple boxes is the idea when you need to update the data, so you need to visit all these little boxes to make the change and update at the same time. So this matter of consistency, where you have two little boxes, easier to update, takes little time. And about how fast you retrieve the data, I think having multiple boxes, small boxes, is faster than the bigger box, because the bigger box or the big server, you have lots of, you have to force yourself to save too much data in each box, because you have only two boxes. The retrieval time will be like more than saving these data, distribute these data in little boxes, which it's going to be fast. The right time will be faster than the.
I think this is dependent on the communication layer.
Yeah, assuming that you have the same communication, same bandwidth. So only the matter I'm talking about, the only thing, the variable is the size of the data. Everything the same, only the size of the data. The little boxes, the size is going to be little than the bigger boxes. So this time, the time takes to retrieve the data from the little box will be faster than the big boxes. Assuming you have the same bandwidth, same.
I mean, depending on the streaming algorithm.
Yeah. Again, same.
So
I'm just like here.
I think if you have multiple small portion of distributed, it will be less risky and more efficient.
Risky in security?
And maybe sometimes if damage, crash, other aspects also. So we should be careful about the possibility and probability also.
Yeah.
Also, for purpose processing, if we have multiple models, it's easier than we have one interaction.
So it's always the best choice?
No, sometimes.
Okay, so what are the cons?
Sir, I think it all depends upon what you want. You want the bandwidth or data storage to save, you want resources.
If you ask any competitors, they don't want to spend money, they want fast, they
like
want
if you're
consistency.
like, you want security, you don't want a single point failure. Like which of those is your priority?
So which one do you think is more secure?
Sorry.
Multiple.
Not the multiple.
Two boxes.
Yeah, multiple.
Yeah. Often enough that case is more secure when you start. And performance, actually, we were both right. All of you were right. Performance, the problem is the networking models we have is not set up to deal with that. So we have lots and lots of boxes. We just don't have the protocols for it to make it work. I mean, Hadoop and all these other initiatives are attempting to go a little bit down that route. But at the end of the day, so there's something completely called virtual networking. So there are people who are working on virtual networking because the current standard networking models we have doesn't work. Right? It is set up with having big boxes, a few of them working. So you have thousands of boxes who just don't have the protocol to work. And the question of replication, bandwidth, use all those things come. But yeah, but at the same time, point of failure, your bottleneck, you put in the processor being busy. Right? On the other hand, suppose you have 20 boxes and you give a job to the 19. How do you know his processor is ready and able to go? Because we don't even have any schemes that decide. Like when you have one machine, you can look at the loads and go down the list, right? When you have 200 machines, How do you know which machine now can do this job for this long? Right? So it's a dual problem, but it's an open research problem. So it's a very big thing, and I think that's why you look at the companies, big companies like banks. I'm very surprised to hear Reza says that banks would consider Hadoop or anything like that, because they don't want to take the chance. Security, fault tolerance, time. I mean, already 120 million. So many of them don't want to switch out. But if he can solve it or take a dent in it, it's one thing. I have another question. So you have NoSQL. So what type of data they had it in mind when they started?
Sorry?
The type of data.
Well, that's exactly the parts that I'm going to describe. Okay, if I want to reveal it, I'm getting ahead of myself. Okay, it's going to. But thanks to Professor, I just recall something. You know, the idea of having great computing and cluster computing belongs to 10 years, a decade before we had these companies, and the project was started. But then it was SETI at home. SETI at home, and the guy which was behind this project had two big ideas, because the servers for weather forecasting and for making models for curing HIV disease, they need very high intensive resource consuming processors. So he came up with this idea that I'm going to distribute the process for process intensive projects. In the time that the price of power is low, and the time that most of the machines and computers they do not occupied by any real world, like midnight or something, or when they go to the standby form or the screensaver comes, it could be a kind of alarm. And the project name was SETI at home. And after a decade, they started to think, okay, that was not a bad idea. Why don't we think about the data processing and the intensive environments? And Hadoop was one of the answers to this 3 years. Okay, historically, we are done with this. First of all, for example, the models that they started to say, they said, okay, the key value for, suppose that we had a flight number and the information about that flight, the other flight number and the information. So we can consider this one as a kind of key and the rest of the thing as a kind of value. Or suppose there is a kind of sale, because I'm going to use this example several times. Suppose the name of this Best Buy branch that we have in Donetsk, it's 10. And suppose there's a kind of laptop there, it is 105079. That's a kind of Toshiba, suppose, or something. And we want to have the summation of the laptops that this store sells each day. Okay? It's pretty easy if you consider this 10 as a key and the number of this are value. Okay. But the problem starts when we want just to switch these two. Okay. And to change, to swap the key with the value. So this is the thing that I'm going to take care of a little later. Another thing that I'm going to talk, the other model was, they call it document data model. Well, it's pretty similar to what we have in XML environments. There's a kind of ID there, and XML. It's not, I cannot say it's unstructured, but we can say semi-structured environments. Okay. So we have a kind of ID, and the rest of it is information about this. And we had column family. Suppose just think as a kind of analogous to Excel sheet environments, pretty similar to Excel sheet environments, but each column could be in separate files. Okay? For example, we have a row here. It could be in one file, and the other name could be in another file. But if you look at it from far, it could be something like, merge them together, but something like Excel sheet. But there isn't any specific separate line between these models after a few years, because, for example, in key value, you have the metadata in the value part, which is pretty similar to document data model. In document data model, you most of the time you have something as a kind of initial key, which you can consider as a key value. But you can, put them all under the umbrella of aggregate-oriented, and they are not passive. Okay? There's a kind of common mistakes that we all deal with, and we think that all NoSQL data are not acid, but graph is absolutely acid, atomic, consistent, isolated, and durable. Durable. I went to one store and I said, I just want a camera which is durable. I said, what's it? I said, durable. I said, oh, you mean durable? So I started to, correct my pronunciation, it's Canadian. Anyway, so I promised to just skip that. Did you get the answer?
Yeah.
Okay. Just 73 left.
Yeah, but you were making an example that you saw companies like Google, or Yahoo, etc. The type of data they usually handle and care is very different than, say, government or bank or financial institution. So they don't care about many of the issues that may happen if your data is lost, modified.
Exactly.
So it makes a different story. So you lessen or remove some of the requirement you have in RDBMS. Because that is built into that. I got to make sure these things is true. For example, you pointed out to the write. Write is a very important thing. I can never overwrite, because if you have multiple users kind of accessing it. You do video, somebody kind of erases yours and put another one. Very simple. So I think some of that early work, start listening that in order to get to something that's less structured. But when you go back and you say, I want to now use it in every application, then you have to bring those things back. You may not want to.
Unfortunately, just to raise it's a very good point that you brought to this time. Exactly. It was one of the presentations belongs to one of the implementers, the developers of the Hadoop. He said, what is important for us? Do you remember the isolation rules that we had? For example, if somebody wants to manipulate any record, we just make a kind of log in here. And during the time that this person is going to manipulate this, nobody can touch this data. Okay? You remember that? So there was different solutions for that. But this is the impedance problem that I told you. What is important for Amazon? Is it important, for example, to bring just one false result among thousands to one customer? Or to lose 100 customers because of this issue? Which one is more important? Which one is the most important thing in all North America? Buying. Okay? The more you buy, the more successful your company is. So we should take care of this issue. Okay, Amazon tells you that I have this book, and unfortunately, when two people at the same time wants to buy that, and they both of them get the correct answer, okay, we can just say, okay, forgive me, we will offer you later. There's a kind of problem, and we just get rid of it. It's not that much crucial. But in banking system, you're absolutely right. I remember this one time, because in the place that I worked, there was 2 stores over the branch, one of the branches. And one of the employees told me once that for 1 cent, there was an old lady came and fight. You know that you are cheating. You didn't give me enough interest just because of 1 cent or something less. Okay, because some of the people just want to calculate and see if they get enough interest or not. For commercial environments, that's absolutely correct. But for this kind of an environment that I made an example, but it's not a bad solution. Okay, let's go further. So easier development.
This must have happened to you as well, no? I have bought stuff and you check out and then it comes and says, no, you didn't buy this. It's not in the stock. So wait a second, what do you mean it's not in stock? I actually clicked it and I went, it's not there. Okay.
So, and well, I just want to tell these kind of things clearly because it was very blurred and ambiguous for me at the first. So is Hadoop a kind of operating system, or is it synonym to the MapReducer or these kind of things? I just can say Hadoop is a kind of idea at first, and then I can say it's a kind of framework that gives you a plain environment in order to use your services inside, like MapReduce and the others. And the services inside Hadoop, we call them den, because it's Linux, as you know, and the services are denser, like MapReduce or the other things. So, velocity, volume, and variety are triple V that Hadoop is going to tackle, because the speed, the pace of the information that we are dealing is tremendous, as well as having big amount of data and the variety of the type. And I'm going to tell you in chapter 3. It is possible to implement your own classes. Okay, so if you want to bring big data to a powerful computer, it is possible, but up to a certain level. After that, well, we deal with a huge problem. What should we do? We can, split our data into a small portion. And there's, I just want to tell you two things. The book that we are concentrating works with Hadoop version 1.2, and the recent version is more than 2 point something. And unfortunately, there are some unavoidable problems, like the thing that it says about XML and 5. It has changed absolutely, and it mentions that the part of data that we use in Hadoop, what do we call it? Everybody knows. Please help. Is it chunk? Let me make it kind of test. Or is it block? Or is it data split? What do we call it? Chunk? A, B, C. You said chunk? Okay, no. Chunk is the terminology that we use in Google language. Okay, it is block. And the restriction is the default amount is 64 megabyte, which is absolutely manageable. We can change it to 30 to 120%. But it is mentioned data split. It's not right. It's in the lower part of page 36. I just wanted to tell you, don't think that it's Bible and everything is fine with it. Okay, we have MapReduce and file system. HDFS is one of the file systems that we'll be dealing with. And if we have this commodity of computers, for sure, OS is kind of layer in here. And we have kind of invisible layer, which deals with HDFS, Hadoop Distributed File System. Okay, it gives you a kind of feeling. The name is exactly opposite. They call it transparency. It brings you the transparency in distributed environments. Okay, and you think that it's not important for you where the actual location of your data. Is it in the United States? Is it in the Middle East? Is it in Europe or somewhere else? Okay, so and HDFS is a kind of environment that deals with a huge file, which could be a kind of overwhelming process for the rest of files. Thank you so much. Super simple. And we have a bunch of projects there. You are done enough with this shape. Everybody told you, and you know the low-cost computers here, and the base platform is Linux. But for sure, we can use Sigwin. Do you recommend it? Fatima, do you recommend Sigwin? I faced a lot of problems. Sigwin is a kind of simulator for it. Yeah.
If you need to work in Windows with the Linux, you can run it. For me, it doesn't work very well.
For me as well. So that is why.
So it's better to install like a VMware or whatever virtual machine. It's better than run a Sigwin.
You know, for me it's like this. And when I started, I said, okay, let's bring this question to my friends. And this, for example, between different virtual environments that we have, one of them is VMware, the other is the box of Oracle. So I just wanted to ask which one is better. I started to read and I said, okay, just 2 days left and let's get rid of this. And for next presentation, I'll bring you the result. Which environment can be safer for having on the Windows operating system. Okay.
Did you all try to create play around with it? We talked about it a few weeks ago. What should people did manage to try?
Did you get some?
You tried the engine?
Sorry.
Was it good? So lovely, actually. Yeah. From time to time, you actually appreciate somebody else's work.
Okay. So you know the architecture of master and slaves, job tracker, task trackers, and these kind of things. And okay, just one thing. This is the slide that I stolen from Fatima's presentation. You remember this point when we had a huge, for example, amount of data here, and he wants to split this data into different common computers or segments. We have a kind of mapping or macro processing here, and we have reducer in here. But the result of this part could be, we're going to talk about, could be, for example, I'm going to see how many cars do we have. Is it more appropriate to have, suppose, 273, car 1, car 1, car 1, or it's better just to send car with 273. So in some references you can see before shuffling phase we have combined here. And also suppose that we just want to take care of the characters which start with A, B, C or something. Is it possible to just send them randomly to reducer? Or reducer will appreciate if it's possible to receive the sorted amount of data. For example, the one which starts with A, B, or C. So in some references you can see partitioner, which can instance exactly before reducer.
I saw in some of the slides, between reducer and shuffling, they have one more filtering and more, as you said, alphabetically, and then a separate column is still there, which will give you more concise results before reducing.
Well, I don't want to get ahead of myself right now, but as you said,
like a custom made for problem, right?
But they can add a they run the class is already built and
You just call it?
You just call it. You have to define it at the beginning. If this job will need this configuration, you add it just at the beginning and assign some value on it.
Okay. Thank you, Fatima. And you know that one of the benefits, one of the positive points in here is its fault tolerance. So any data node goes down, because of the number of replication that we are dealing with, we can count on the others, and exactly immediately the Hadoop environment is going to make a kind of replication for that. For example, if we have the replicate factor of 3, and we just we just lose one of them, it's going to replicate another one in another server. And the number of computers, if they go further than 20. Apart from computer, fault tolerance level, we should take care of the rack level. Means if, for example, we have different racks and we have a bunch of computers here, we shouldn't just keep all 3 replications in one rack. But it's better to have 2 of them in one and the third one in the other. We always have to, be loyal to this architecture. And we have the task tracker
ask you a question, because it was in not this presentation in general. But number 20, I'm suspicious. Why?
Well, if you ask that, why 20, the answer could be why any other number.
Why another number? Okay, thank you.
But, to be honest with you, I checked. There are some, factors. For example, why 3 replication, not 2? Why exactly? There's just kind of default for it, and it's a kind of XML. And I saw a bunch of papers, and they changed this predefined setting in order to show that if you, for example, change this factor from 2 to 3 or to 4, you reduce this amount of performance and you gain this amount of result as well. So it's just kind of predefined. It's possible to change it. It's not necessary.
But that's not 20 depends on many factors. How many replication you do, what kind of machine you have, how big of data you have.
I can say the Hadoop by itself is it is in the infant level. Okay.
So somebody had to come up with a number and 20 was a good number?
I think.
Is that your opinion? So I read it in the book, but I was just curious. This seems to be a very definite number.
Maybe it's more. But they started when
But the papers you read, the 20 is also the optimized one, or is it?
No,
Or they say if you make it 25, it will be more better.
Well, let's put it this way. If you have more than 20 computers in your network, it shows that maybe, apparently, your data is a kind of crucial data. Okay? So it is better to take care of the security. To think that we have this data as a persistent information. Okay? So we should think about, if anything happens for the rack, entire rack, we should have the kind of replication for that. Okay? I think it's just a kind of why.
So they support the fact that 20 is an optimized number in your...
Yeah, it's a kind of.
So is this first have been chosen by Yahoo, for example?
Yeah, no, not by Apache.
Yeah.
And the XML file that is for.
So it must be based on experimental work to maybe to optimize different factors. They count 20, and then the people after that they still keep this number when they do the carry out the research work or the industry. They just keep it, so they don't bother themselves to do more experiments to see some other number maybe give more optimized results.
Exactly. I think based on the information that we are telling, it can change from the computer, from the project.
But I said it's the XML file, we can change it.
Yeah, definitely.
So,
Sure. When the professor asked this question, I exactly recall it. 10 years ago, it was more than even. I just started to work as a teacher in MFT, one of the colleges in Iran. And I started to teach VBA and Excel and these kind of. Whenever you open Excel environment, it has 3 sheets. It had 3 sheets by default, and all the time there is just one student who said, "Why 3 sheets? Why 3 sheets?" And I said, if you ask why, if even I ask Bill Gates, I'm sure that any number that he has.
I have an answer for you. 14-inch monitors.
Sorry?
14-inch monitors. You're too young. Monitors used to be very small. In fact, it was 12-inch. So there was just so much room to see on the screen. So think about it. You open a spreadsheet, you want to put tab. How many tab you put before you run on the screen?
That's the reason?
Yeah, and they never changed their codes, legacy code, so they eventually will change it. I think that's why it is.
But, the good news is I recently wanted to work with 2015, and I opened the Excel sheet and I said, wow, just one sheet. Thank God. After 10 years, I shouldn't, answer to this question, why 3 sheets? Anyway.
I have one more question for you, actually, for those of you who actually play that on and implement it. So you have an architecture, right?
Yeah.
Your architecture, your controller, your master slaves, all these kind of things.
Yeah.
Are they all implemented at different hosts, or some of it actually are done, say, at the router level?
Okay. You see, there's this ability for us to have different XML environments.
Yeah.
If you want just to work in your personal computer and resemble and simulate the environment. It is possible for you to do all the things inside just one computer, just to make sure that you